worked with exponential functions, and we talked about that really means that your variable is in the exponent. And we're going to continue with that today, expanding to more specific exponential functions called exponential growth or exponential decay. Based off of your graphs from yesterday, describe what the word exponential probably means.
It goes up.
And describe how it goes up.
Bigger every time.
Yeah, fast, right? It quickly accelerates or it quickly decelerates in our brains, right? Okay, so exponential means it's going higher and higher, faster and faster, or it's going lower and lower, fast. It's not open, is it? Gosh, terrible at this. So exponential growth obviously is getting bigger. Exponential decay is getting smaller. So look at the difference in those two equations. Refresh your stuff. It should be there now. What do you notice?
One of them has plus sign, one of them has minus.
Okay, very straightforward, right? Adding growth, subtracting is decay or going down. Okay? In this problem, A is going to be your initial value. A is your initial value or your starting point. R is your rate. Now, they're going to give it to us in a percentage. Guess what we're going to change it to? A decimal. And T is time. Usually in years, we have to read the problem carefully, but usually in years. You have to memorize these equations. I will not give you these. They are not going to be on Alex. They're not going to be on your paper. So what I encourage you today is you write it down on every single problem so that it gets drilled into your brain, and then pretty soon you'll be like, oh, no big deal. I'm going to tell you between today and tomorrow, I'm going to throw and yesterday, a lot of equations that you have to remember. You have to remember y equals a times b to the x power from yesterday. Today you have to remember a times 1 plus r to the t and a times 1 minus r to the t. Nice thing is, small change in there. So a problem looks like this. To begin a bacteria study, a petri dish had 1,700 bacteria cells. Each hour since, the number of cells has increased by 1.1%. Let T be the number of hours since the start of the study. Let Y be the number of bacteria cells. Write an exponential function showing the relationship between Y and T. All you're doing here is writing an equation. You're not solving anything. You're not making any calculations. Here's my question. Exponential growth or decay? How do you know? Very good. The word increase. Y equals a parenthesis 1 plus r raised to the t power. Now notice right here it says between y and t. That means y and t are staying in your equation. We need to replace a. We need to replace r. Which one is which, or what should I put in for them? Okay, and what do I want to write my r as? Because I don't want it as a percentage. 1.1% really becomes 0.011. Yes? What's my a value? 1,700. Parenthesis 1 plus 0.011. Close your parenthesis, raised to the power of t. There is one thing we should do before we would type this into Alex. Guess what it is? You can't distribute. Actually add these together. So y equals 1,700 times, very good, 1.011 raised to the power of t. Now, we really can't do anything with this because we don't know how long t is and we don't know what y is. They're asking us purely, can you take the information to figure out what your initial value is or your starting amount and your rate? Question.
Yeah, so like why do we do that certain decimal and not a different decimal? Because you can make a lot of different decimals out of this.
What do you mean?
Well, like it could have been 0.11 or
Why is it 0.011? Percent means what?
Out of 100.
Out of 100, right? So really this is 1.1 divided by 100.
Oh,
And when you divide by 100, it moves you over 2. Yep. That's why you always move it 2 decimals. Okay? So now let's evaluate or interpret what my function means. A can of soda is placed inside a cooler. As the soda cools, its temperature, C of t, in degrees Celsius, after t minutes is given by the exponential function. C of t equals 21 times 0.96 to the power of t. Find the initial temperature. Is it growth or decay? And by what percentage does the temperature change each minute? What's my initial temperature? 21 degrees. 21 degrees. The number multiplied by your change, your A value. Growth or decay? How do you know? Bingo. 2 things. It says it cools, but also that inside your parentheses, if it's larger than 1, growth. If it's less than 1, decay. By what percent does the temperature change each minute? Amber? How'd you get 4? Very good. We started with 100, right? We started with 1. Now we're down to 0.96. Remember, it was 1 minus r, and we know that that's got to be 0.96. Well, what did I subtract? 1 minus 0.04. 0.04 as a percentage would be 4%. Nicely done. 4%. Good observation as far as being above 1 or below 1 as growth or decay. And basically, you're trying to find how far up or down are you from 100%. Questions on being able to identify pieces of that function. Okay, let's get to the nitty-gritty. How do we actually use this? So the dollar value V of t of a certain car model that is t years old is given by the following exponential function. V of t equals 26,000 times 0.95 to the t power. Find the initial value of the car and the value after 12 years. Round your answer to the nearest dollar if necessary. One of those, we have to do 0 calculations. Initial value is how much? Very good. My initial value is 26,000. To calculate after 12 years, where's 12 going? On the t. So we have V of t equals 26,000, 0.95 to the t power, but we're putting a 12 in there. Order of operations. What do I do first? Exponents. Grab your calculator. We need to practice how you put this in because Ms. Hoff can't help you when it comes to your test. So we need to type in, you guys asked me about this a couple weeks ago, 0.95, and somewhere on your calculator there's like a caret key or an exponent key, and then you need to type 12 and hit equals. Now, it is going to be a nasty decimal, agreed? Okay, this is one of the few times, don't be shocked here, that Ms. Hoff isn't expecting you to have work midway through because we don't want to round that. We want to use that entire decimal. So what do I need to do with that amount? Very good. So don't clear anything. Just hit your multiplication button of 20 and then type in 26,000 and hit equals. Now note your directions say round your answer to the nearest dollar if necessary. That's a whole number. That's a whole number. What are you rounding to? Round to the nearest dollar, whole dollar. So 49's good. Does it make sense that my value of my vehicle went down? Yeah, because your car depreciates. As much as we would love to say it gets more, it depreciates. In 12 years, they lost $12,000, almost. Questions? Okay, let's do the next one. This one, they're not so nice. They don't, oh wait, just kidding. You do this one on your own. You're just writing a function. There's a sample of 700 milligrams of a radioactive substance to start a study. Since then, the sample has decayed 8.5% each year. Let T be the number of years since the start of the study. Let Y be the mass of the sample in milligrams. Write an exponential function showing the relationship between Y and T. You're just writing me the equation. Minus R plus R. Minus, because of the word decayed. What's my initial value? 700. 1 minus 0.085 raised to the power of T. Don't leave this. Don't leave this. Actually make this calculation. Y equals 700 times 0.915 to the power of T. Yes? Yes? No? Yes. I have very puzzled looks. Where are we at? We're okay? Kind of.
I just don't like word problems.
The thing is you're looking for what they tell you started with, and you're looking for the word like a decay or a growth, and a lot of it's just fluff. They're trying to confuse you. Okay, so the other part of what we're going to do today, I'm going to throw another formula at you, is compound interest. Compound interest can be a beautiful thing, and it can be a terrible thing, depending on which scenario you're in. So interest usually, I shouldn't even say usually, sometimes interest is only earned every year. So at the end of the year, it's based off of it. Compound interest means that you earn interest sometimes annually, semi-annually, weekly, monthly, bi-monthly, different number of times per year. Okay? So the only difference in this problem, whoopsies, the only difference in this problem is now we have a letter N. And N is going to stand for the number of times compounded. Now, Ms. Hoff, you say sometimes it's hurtful and sometimes it's helpful. Okay, on your house mortgage, every month they recalculate how much you owe them for borrowing money. That's hurtful. You have to pay more. But on a savings account, every month they give you money for having money in their savings account. That's helpful for you. Okay, so different depends on if you're talking about a loan or you're talking about a savings account, whether it's beneficial or not. Okay, if you think of annually, how many times do you think you earn interest? One time a year. Just a chubby cat. Semi-annually. Semi-annually. 2. Weekly. 52. 52 weeks in a year. Monthly. 12. Bi-monthly. 24. I would say bi-monthly is probably rare. Okay. All right. So if you have to look for the phrase compounded, like in this one, compounded quarterly, then you know you need to bring in that letter N. Suppose that $2,000 is invested at a rate of 4.2%, compounded quarterly. Assuming that no withdrawals are made, find the total amount after 9 years. Do not round any intermediate computations and round your answer to the nearest cent. What they're saying is you're going to use your calculator quite a bit. Okay? And you're not going to round anything until the very last part. So first things first, let's talk about our equation. A equals P 1 plus R divided by N raised to the N times T. When they talk about compounded a certain number of times, we have to bring that into our rate and our time. I'll be honest, I don't love that they changed the letters to A and P, and I don't know why. P usually stands for principal or the amount. Okay, so in this case, how much are they starting with? $2,000. 1 plus, what's my rate? 4.2, so you, very good, 0.042 divided by how many times is it compounded? 4, compounded quarterly. It's not time. It's in 1 year. How many times is it compounded? 4. Close your parenthesis. Now we have to take n times 2. You just told me how many times is it compounded? 4. How many years? 9. Now part of this we're going to use in our calculator, but part of this we're going to simplify before we try to use our calculator. The one thing I would tell you is to do this first before you do any other calculator work. 2,000 times 1 plus 0.042 divided by 4 is really going to be raised to the 36th power. Okay, everyone grab your calculator. Because at this point, Miss Hoff isn't expecting intermediate work, which usually is weird, right? Like usually I want you to show some stuff in here. This is all on the calculator. What is the first thing I should type in? No. Because what are we, we need to go inside our parentheses, and inside our parentheses we need to divide. So first you would type 0.042 divided by 4. Hit the equals button, and you have a number on your screen, yes? Now what do? Plus 1. Hit the equal button. You have a number on your screen. Now what do? Caret key to the 36th power. Hit equals. You have a number on your screen. And then we multiply times 2,000. Hit equals. This is your final answer that you need to round to the nearest cent. $2,912.98. If you did not get this, let's do this again. Did you hit it too many times? Okay, do it again. I just want to make sure that did it show up actually? Okay. I just didn't want it to give you that on your deal. Questions?
I don't think I have a carrot.
You have this button right here, which is the same thing. Yep. So type that in there. Yep.
Again?
I'll do it. No, not a lot. I just want to try something else. This is like good morning. I want to do it. I got it.
Yeah, you probably don't have the right decimal in there. Okay. All right. I want you to try Maria's parents' problem on your own. Maria's parents invested $14,000 at 6% per year, compounded monthly. How much money will be in the account after 10 years? Create the equation. Create the equation. So I got 14,000 times 1 plus 0.06 divided by 12 raised to the 1/20th. Okay, how much money's in the account? Anybody else get that to back that up? Yep. $25,471.55. Question. Yeah, if it doesn't say to round to the nearest, it will tell you if it wants you to round any differently. Because it's money, always go to the cent, except for that 1 cent round to the nearest whole dollar. Yep. Question. Yep. Anything else? You're absolutely going to need to show me some work today. Okay? Don't visit. You know that drives me absolutely bonkers. Get started.